Hello everyone. So today in this video we are going to solve a question of LeetCode. Today's shortest unsorted continuous subarray. This is 581 question on LeetCode and this comes under medium category. Alright, so let's start with the problem statement. Given any teacher array nums, you need to find out one continuous subarray that if you only sort this subarray in ascending order, then the whole array will be sorted in ascending order. And at the end we need to return the size of that subarray. So let's see in the first example we have this subarray 6, 4, 8, 10 and 9. If we just sort this subarray, then definitely the whole array will be sorted. Okay, so whenever we see these kind of questions of subarray, so the basic approach which comes to our mind is two pointer approach or sliding window approach. But in this question I don't think we can use a sliding window approach because the size of window is not constant. So let's try to use two pointer approach in this question. Okay, so let's take the first example. So let me make a multi-line comment here. Yeah, so in this let's take two pointers. First one is L and second one is R. Okay, so when we just try to move this L and R according to two values. Okay, so let's try to find out. Let's see in the first two values, this is already sorted in ascending order. So let's increment L from here. Now let's see these two values, these are not sorted in ascending order. Let's stop L here. Okay, now let's deal with R. Now for R, these two values are already sorted. Let's decrement R from here. Okay, now this is not sorted. 10 and 9 are not sorted in ascending order. So we will just stop L and R here. Now we have got this subarray. So when we will just sort this subarray, then definitely we will get our correct answer. And this will become sorted. So we will just return the size of this subarray. So the size of this subarray is basically R minus L plus 1. Okay, so this will work fine for these three examples. But if we take another some custom example, like if we put some small value in between, then it will not work fine. So let's first code the solution for these example, then we will try to find out the code for the another custom example. Okay, so let's quickly code the solution for this example. So int L is equal to 0 and R is equal to nums dot size minus 1. These are basically the leftmost and rightmost pointers. Now let's run a while loop until L plus 1 is less than nums dot size and nums L should be less than equal to nums of L plus 1. And let's increment L from here, and then let's run another while loop until R minus 1 is greater than equal to 0 and nums of R minus 1 is less than equal to nums of R. And let's decrement R here. We are basically checking the two values. For L we are checking L and L plus 1, and for R we are checking R minus 1, that is this one, and R. So when these condition will become false, then these pointers will stop at their respective positions. Okay, so let's check for this second example. In the second example we have the array is already sorted. So when array is already sorted, so after running these while loops, L will come to the last index. So when L is at the last index, so there is no subarray. So what will happen? We don't need to sort any subarray because it is already sorted. So we will just return 0 in this case. Okay, so let's see if L is equal to nums dot size minus 1, then return 0 from here, else we will just return the answer, or we can say the length of this subarray. So return R minus L plus 1. Okay, now let's try to run it. Yeah, it's working fine. So this will work fine for these examples. So let's see a custom test case. Let's say we add a smaller element in between. Okay, so let's say we have added one here. So it will definitely give us wrong answer in this case. Okay, let's try to run it. Let's see. Yeah, you can see this is given wrong answer. So let's try to fix this. So let's say we have added one in between of this L and R. Okay, so what will happen when we sort this subarray according to these given L and R position? So this will give us something like 2, 1, 4, 6, 8, 9, 10, and 15. Okay, so we have just sorted this subarray, but still the whole array is not sorted. Okay, so the conditions are not true. So what we will do, we will just try to shift this L pointer so that these two values are also sorted. Okay, so how we will just shift L and R, that we need to fix it here. So we can see the values on the left side is greater than the minimum value, that is 1. So what we need to do is we need to shift L to left side until the values is less than, or we can say until the values are greater than the minimum value. If it is less than or equal to the minimum value, then we don't need to change the position. But if it is greater than the minimum value, as in this example minimum value is 1 but 2 is also here, so when we will sort this array, then definitely this will not become sorted because 1 will always come after this 2. Okay, as we have seen here. So what we need to do is we need to shift this L until this value on the left side is greater than the minimum value. Okay, so first let's find out the minimum value in this LNR range. Okay, so let's first take two integers. Int low is equal to int max, this will be storing the minimum value, and int high is equal to int min, this will be storing the minimum value. Okay, now let's run a for loop. Int I is equal to L, I should be less than equal to R, and I plus plus. Now let's update low is equal to minimum of low comma nums of I, and high is equal to maximum of high comma nums of I. So this will store the minimum and maximum value in these variables under this range. Okay, so now let's run two while loops to update the positions of L and R according to the lowest and highest value. So let's run while loop until L L minus 1. Okay, so L minus 1 is greater than equal to 0, and nums of L is greater than minimum value, or we can say it should be low here. So until these conditions are true, then just decrement L, and for R let's say R plus 1 is less than nums dot size, and nums of R should be less than nums, this should be less than highest value. Okay, then increment R from here. I hope it should work fine. I think this should be L minus 1 here, and this should be R plus 1 here, because we are checking the left side. L is here, we are just need to check the L minus 1th, like the left sides, and the position on the right side, because we have already checked the Lth position. Okay, so this should be L minus 1 and this should be R plus 1. Okay, so now let's try to run our custom example which was wrong answer earlier. Okay, let's try to run it again. Yeah, it's correct now. So let's just submit it. Yeah, it's working fine. So let's calculate the time and space complexity of this solution. So the time complexity of our solution is big of n, because we are traversing through all the n elements, and Space complexity is bigger of 1 because we are just storing the constant elements here. Okay, so I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. Thank you.